For numbers 24 through 30, we are told that we have a figure called ABCD and that it is a square. Now, squares have 10 properties that we know about their sides, angles, and diagonals. But since we're given the coordinates of one of the diagonals, we're only using the properties that have to do with the diagonals of a square. There are 3 of them. The first one is that the diagonals have to be congruent. The property that the square's diagonals are congruent comes from the fact that all squares are rectangles. And we know this to be one of the properties for rectangles, that their diagonals are congruent. To show that the diagonals are congruent, we're going to be using the distances between the vertices to show that they have the same length. So we want equal lengths to prove that they are congruent. The diagonals of squares are also perpendicular, and it gets that property from the rhombus. All squares are also a rhombus. And so we're going to be using slope to show this property. Now, the slopes of perpendicular segments are not equal like lengths are. The slopes of perpendicular segments and lines are opposite reciprocals of one another. And so both of those things have to happen to the slope, the change of the sign and the flipping of the fraction. The diagonals of squares also bisect each other, and that's simply because they are parallelograms. And that's one of the 5 properties of parallelograms, that they bisect each other. To use that property, we're going to be finding midpoint. For 2 segments to bisect each other, they must have the same midpoint. So the first thing I would do is plot your 2 endpoints that you're given, which are -2, 1, that's point A, and 6, 3, that's point C. These are not 2 consecutive vertices, so that does not make up a side of the square. The sides of the square will be AB, BC, CD, and DA. So when you connect 2 non-consecutive vertices, that's a diagonal. So the distance between these 2 points is a diagonal when we connect those. So the first thing we're asked about is to find AC. Remember, when you see 2 points next to each other without a segment bar above it, it's asking for the measure of that segment, or in other words, the distance between those 2 points. You have 2 options to find the length of AC. You can focus on a right triangle here by either going straight down and straight over, or straight up and over between point and point. So if you do that, you're finding that vertical distance is 2, that horizontal distance is 8, and you have the distance between A and C, that's the hypotenuse of that right triangle. So you would be solving the Pythagorean theorem, 2 squared plus 8 squared equals C squared. So since 2 squared is 4 and 8 squared is 64, you get 68 is C squared, and you have to undo the squaring by taking the square root. So you get the square root of 68 is C. Now remember, you would never put an unsimplified radical as your answer ever. So just as a review on how to simplify radicals, you can go to your y equals on your calculator, put the number that's underneath the radical, which in this case is 68, and divide it by x. So you're just asking your calculator, what are all the values that divide into x? Remember, you're not putting in the square root of 68, you're just putting the number that's under the radical. So now we can look in our table, which is in blue above graph, so we have to hit second table to look at those values. We're looking at the factors of 68, but we're looking for perfect squares. Even though 1's a perfect square, that's not going to be helpful in simplifying 68. 2 and 34 are not perfect squares, and we don't want a decimal factor. In fact, that's been rounded. The next factor pair is 4 and 17. Since 4 is a perfect square, that is a great thing to use to simplify the square root of 68. So we know the square root of 68 is the same thing as the square root of 4 times 17. We can take the square root of the 4, because it's a perfect square, and bring it out as a 2. So 2 square roots of 17 is the length of AC. You could also use the distance formula, which, remember, the distance formula is the square root of the difference between your x values. So 6 minus a -2 would be the same thing as 6 plus 2 squared, plus the difference in your y's. So 3 minus 1 squared. So 6 plus 2 is 8, so you'd have the square root of 8 squared plus 3 minus 1 is 2, so 2 squared. 8 squared is 64, 2 squared is 4. Again, we get the square root of 68, which we already know is equivalent to 2 root 17. Make sure you always check that you simplified that correctly, and the way to do that is to get out of your y equals, put in the square root of 68, and get it as a decimal, and then put your simplified version, which was 2 square roots of 17, and you should get the same decimal answer since these are equivalent to each other. So that's just a good way to check and make sure you simplified it correctly. Now, since I know that the distance between this diagonal, between points A and C, is 2 root 17, and I know that the diagonals of a square are congruent, then I also know when I connect the other two non-consecutive vertices that that diagonal is going to have the same length. So without even knowing what the vertices or what the coordinates of B and D are, I know the distance between the 2 points because the diagonals are congruent. The next thing that's asked for is the slope of segment AC. You have 2 ways to find slope as well, just like there were 2 ways to find the distance. To find slope, you could look at your graph and look at the rise over the run. So we already saw that the rise was 2 and the run was 8. We could tell it was a positive slope since it was going uphill, and so our slope would be rise over run, and make sure you always simplify that. So that simplifies to 1/4. The other way to find the slope is to use the formula, the difference between your y coordinates over the difference in your x coordinates. So you would have 3 minus 1 over 6 minus a negative 2, which is the same thing as 6 plus 2. So you would have 2 over 8 is, again, which is 1/4. Now remember, that doesn't mean the slope of your other diagonal is also 1/4. If it was also 1/4, then you would be saying your diagonals are parallel, and that's not true since they intersect each other. Remember, the slopes the diagonals are perpendicular, which means their slopes are opposite reciprocals of one another. So we have to change the sign, which means our new slope is going to be negative, and flip the fraction, which becomes 4 over 1, which we know is, of course, just 4. Always write the simplified version. So the slope of the other diagonal has to be negative 4 in order to be the opposite reciprocal of the other one. And then finally, we're asked to find the midpoint of segment AC. To find the midpoint, you're just finding the point in the middle, and that means you're going to find the x in the middle of these x's and the y in the middle of these y's. And to do so, you just average your x's, that means add them together and divide by 2, and average your y's, which means add them together and divide by 2. So when I do that, my x's are negative 2 and 6. I'm going to add them together and divide by 2. My y's are 1 and 3. I'm going to add them together and divide by 2. So I get my midpoint of segment AC to be 4 divided by 2, which is 2, 4 divided by 2, which is 2, the point 2, 2. Since the diagonals bisect each other, remember that means they have the same midpoint. So the midpoint of the other diagonal will also be the point 2, 2. So this point right here is the midpoint of AC, and it's also the midpoint of BD, wherever B and D are. So after getting all of this information, we're ready to find the coordinates of your other diagonal. Now to do so, remember all 3 of these things have to be true, not just one of them. If you just pick one of these things to be true, then you're only proving it's one of these figures, not a square. So for it to be a square, all 3 of these things have to be true about the diagonals. So since they have to have the same midpoint, I'm going to start at the point 2, 2. And I'm going to use the slope of my other diagonal, which is segment BD. And so negative 4 means I'm going down 4 and running 1. So I can start at 2, 2 and go down 4 and over 1. The coordinates of that point would be 3, negative 2. Now I can also do the opposite. Instead of going down 4 and right 1, I can go up 4 and left 1. That is also a negative 4. So from 2, 2, I could go up 4 and left 1. And the coordinates of that point are 1, 6. So these are potentially my coordinates of B and D. They satisfy the fact that they have the same midpoint, and they also satisfy the slope that I needed to have, which is negative 4. Now I can verify that it also has the same distance as AC by finding the distance between the points 1, 6 and 3, negative 2. So I can use the distance formula here and find the square root of the difference in my x's squared plus the difference in my y's squared. So 3 minus 1 is 2, so I have 2 squared, plus negative 2 minus 6 is negative 8 squared. So 2 squared is 4. Remember, anytime you square a number, it's positive. Negative 8 squared is positive 64. Negative 8 times negative 8 is 64. And that gives me the square root of 68, which I already simplified earlier to be 2 square roots of 17. So since these 2 points have the same midpoint, the opposite reciprocal slope, and the same distance as the diagonal that was given, I feel sure that these are my coordinates for points B and D. Now make sure that you put the correct letter with the correct point. So you can't just put 1, 6 for whichever one you want it to be. Remember, the order of the naming of A, B, C, D means you go in that order, A, B, C, D. So in between A and C this way, we have to have point B. So A, B, C, D. So B would be 1, 6, and D would be 3, negative 2. I'm guessing you could go A, B, C, D as well, so it really doesn't matter which one you call as B and which one is D. So that would be fine as well. So if you called this one B, 3, negative 2, and this one D, 1, 6, that would be fine, as long as you have those 2 pairs of coordinates. So that means if you connect A to B to C to D and D to A, you have created a square.